second part of the derivatives for our neural network based on logistic regression. So, in the previous video, we found out how a small change in A affects the loss function, and how a small change in Z affects the loss function. And right now we are trying to find how a single individual parameters affect the loss function. And we'll try to find out. Just a quick recap. As you can remember, Z is V1, X1, V2, X2, V3, X3, and plus Vn, and it goes like this, and it ends with something, plus B. We remember that. And we also remember the chain rule. For example, this is Z, and we have this is a function, and we have the derivative of loss function with respect to Z, which means we already have this. If we are trying to find, for example, the derivative of loss function with respect to V1, dl and d in V1. It is dl dz multiplied by dz over dw1, because these dz's cancel out when we were left with the derivative of loss function with respect to parameter v1. Now let's calculate this. We already know this, which is a minus y. And what about this? It means we're trying to find a derivative of this function with respect to v1. And if we are doing so, then it means we will treat all other parameters as constants, including b. Then the derivatives of those constants will be 0, and we will be left with just the derivative of this, because it was the derivative of the sum is the sum of the individual derivatives, and all of the sum of other parameters are 0, and we are only left with this, and the derivative of v1 x1 is simply x1, because as you can remember, the derivative of 5x is 5, and in this case the x is v1 and the 5 is x1, because we told in the beginning that we will treat any other parameter as constant. So that's why we were left with x1. So the derivative of loss function with respect to d1, not d1, just v1, is a minus I multiplied by x1. With the same fashion, the derivative of loss function with respect to d, with respect to v2, is a minus y x2. If we write it as a formula, we will end up with something like this. Okay, the last thing is to find the derivative of the loss function with respect to parameter b. Okay, now let's see. Then it's a minus 1, a minus y multiplied by dl db, right? Because this is dl dz. Okay, and as we can see, we said if we treat all other parameters as constants, we're only left with b, and b is x it's the only variable that is changing, and the derivative of x is just 1, then the derivative of b is also 1. So it's simply a minus y. Okay, we were able to derive all of the derivative formulas of any parameter. We really need to do this because we'll use the gradient descent, and we find out that our function is dependent on many variables like v1, v2, b, and etc. And this is the vector. v1, v2, v3, v4, and vn, and then we have b. And we have b. And then the gradient of the gradient that we are looking for is L and Vn, and then we have this with respect to b. Once we find this, this vector is the direction of the direction that we should choose in our input space, and we have to move in this direction in the input space to account for the most drastic change in the loss function. And when we are interested in the minima of the function, we have to find the negative gradient, because we need to find the most drastic change caused by the vector that we are looking for. Because we're trying to find the minima, and we will try to get that minimum point, then it means that we have to find the decreasing direction. That's why we put the negative sign in the gradient. So this vector is the vector along which, if we go in the input space, the loss function will decrease the fastest. And once we find this, we try to find v1 is v1 minus d v2 dl dv2, and we go with the same fashion, and we do it at the same time to all of the parameters. And what it means that we try to get to the minimum point of the function. Because in the minimum point of the function, these will be zero. And once this is 0, then it means our stopping function will be, if v2 is equal to v2 after this operation, then it means we are at converging point. It means that these has become 0. This has become 0, and also we have alpha here. It's the learning rate. It's a parameter that you choose, and you want to choose how many steps you want to go along with that vector. And it's really important because if you choose that lambda to be a very big number, then it might happen that you might miss the point, and if it's too small, then it means that it can take you a long time to reach that minimum point. So once they are 0, it means we are at the minimum point. We're at the minimum point of the function, and then we will end up with the parameters that cause the loss function to be a minimum. And from the beginning, that's our point. That is our goal. So in this video, I don't go deeper into the gradient descent, which is the steepest slope in the function. I won't go into details, but if you are interested, I also have videos on those topics. So it was simply that how we reach a minimum point. I hope I helped you a bit. Even if I helped you a bit, I would be very happy. Thank you very much for your attention. See you on the next explanation videos.